All right, now it's time to find cosine of 45 degrees, exact values, no decimals. So you can't even plug this into your calculator and just get a decimal answer, right? It's got to be exact. Man, what does that mean? Jenny, do you know what that means? She doesn't know what that means. Okay, well, let's think about this. 45 degrees, and we're talking about right triangles. Perhaps I could draw a right triangle with an angle of 45 degrees. Okay? Now, that would also imply that this one has to be 45 degrees so that all three angles add to 180 degrees, right? I'm into that. Now, 45, 45, 90 triangle. We've seen those before. The sides are 1, 1, and root 2 if we're going like the most basic, right? So if I'm trying to find the cosine of 45, let's pick one of these angles to look at it from. Doesn't matter which one in this case because we have two 45-degree angles. So if I look at it from that one, my adjacent side, the one that I want, would be this guy, and my hypotenuse, the other one that I want, would be this one. Cosine is adjacent over hypotenuse, right? We're using ka of SOHCAHTOA. So now, cosine of 45 is going to be the adjacent, which is 1, over the hypotenuse, which is root 2. But as we all know and love, you cannot have radicals left in your denominator. So I'm going to have to rationalize by doing root 2 over root 2, giving me root 2 over root 2 times root 2 is root 4, which is 2. I cannot simplify any further. That is my answer. Root 2 over 2. If you were to type cosine of 45 in your calculator in degree mode, you would get a decimal that would be equivalent to if you were to plug that into your calculator. All right. Perfect. Let's keep going. A couple more examples. Find the sine of 60 degrees, exact values, no decimals, same directions. Now, if I were to draw, once again, a right triangle, label one of those angles 60 degrees, the other one would have to be 30 degrees because they have to add up to 180 degrees, right? Oh, this is a 30, 60, 90 triangle. Who would have thought? So my side lengths are 1, root 3, and 2. All right. Now, since it says sine of 60 degrees, I do have to look at it from this angle right here. Now, sine, I want my opposite, which is over here, over my hypotenuse, right here, right? Sine is the first part of our SOHCAHTOA acronym. All right. I don't care about my adjacent, which is 1. Just care about the opposite and the hypotenuse. So now I have the sine of 60 is equal to root 3 over 2. I don't have a radical in the denominator. I don't have to do any kind of simplifications or rationalizations. Boom, we are donezo. Cool. Awesome. Fantastic. Lovely. Now, they're not always going to have square roots in them. As you can see from this one, if I did cosine of 60, the adjacent would be 1 over the hypotenuse is 2. It would just be 1/2, right? So we're not always going to get crazy things with radicals, but the first couple examples did. How about this one? Tangent of 30 degrees. Exact values, no decimals. So let's drop that triangle, shall we? I think we shall. All right. Now, 30 degrees would be, let's say, this angle here. And then the other one has to be 60. So I am dealing with a 30, 60, 90 again. So I already know my side lengths. Now, tangent is the last one, which would be our TOA, right? I don't know why I did mix of capital and lowercase. All right. So tangent is opposite over adjacent. Now, my opposite side across from the 30 would be the 1. The adjacent side would be the root 3. So now let's go ahead and put this thing together. So tangent of 45 is equal to my opposite over my adjacent. Oh, man. I've got to rationalize. Let's do it. So root 3 over root 3. Now I'm going to have 1 times root 3, which is just root 3. Root 3 times root 3 is root 9, which is just 3. Root 3 over 3 is my answer. That is it. I am done, and I'm done with this video. See ya. Jenny? She's still napping. Adios.